All right, we're live, barely alive. We've had some technical difficulties, but we have Sam on and we have Howard. Uh, Hold on, I'm getting a little feedback here.
Uh-oh.
No, we're good. We're good. So we're gonna see how long
Right.
we're gonna see how long this lasts. And we're here to talk about RandomX. I'm going to keep my video off just so we could use as much internet as we possibly can for communicating here. Howard, I believe everybody is familiar with you and the roles that you play in Monero, but if you can kind of give a quick little intro on particularly what your role has been with RandomX.
Okay. So, I have not been the primary developer of RandomX. That's been Tevador. I guess my role was to be the first one to write up a proof of concept for a randomized, dynamic proof of work. And, that's what evolved into RandomJS last year. It's actually a little over a year ago. I started working on that random code at the beginning of April.
Mm-hmm.
But and so that idea evolved into RandomJS, and Tevador maintained a repo for that, and we worked on that for several months and found some issues with the design that we simply could not fix. And then we dropped RandomJS, and Tevador came up with RandomX. So from then till now, my role has been more of like oversight, technical kibitzer. I also, did all the integration of the RandomX code into MoneroD. So.
Okay. Yeah, we had you on, I guess it's a few months ago now, to talk about where we were at with RandomX at that time. And during that time, it was kind of when the community was making a decision on, what path we would be taking.
All right.
In terms of whether or not we're going to be, when we would be implementing RandomX, and what would happen, if ASICs didn't kind of take over this current proof of work that's out there, what the, going over the different scenarios and trying to figure out under what scenario RandomX would or would not be implemented. So maybe we could touch upon that real quickly. Are we still kind of, or your understanding of that, are we still kind of on the same track in terms of when we would be looking to implement RandomX and under what scenarios we would or wouldn't?
Okay, well, things are certainly a lot clearer now than they were a few months ago. Basically, we are on track. We have 4 independent auditing teams lined up now to, do a full top-down design review and implementation review of RandomX. If these reviews are all positive, or whatever issues they turn up, if there's things that we can fix easily so that we're still in good shape at the end, then we will probably be ready to deploy it this October.
Okay, so that's even if we're not seeing ASICs kind of taking charge of the current proof of work that's out there.
Yeah, that's right.
Yeah. And then, so what was the thinking then with that? It was just kind of like, well, we have it now, we might as well implement it, because it's kind of inevitable for ASICs to take over that existing proof of work, just a matter of time. So we might as well upgrade at this point.
Pretty much, yeah. We know that the last kryptonite tweak is not going to hold up for long. Yeah.
Okay. And are we kind of seeing pushback there from the community in terms of whether or not that makes sense? Is there like majority consensus there? Is it somewhat controversial, or?
I've seen 1 or 2, detracting remarks, but overall the community has been very enthusiastic. When we put up the call for funding to get the audits funded, I mean, the audits were all funded within like 30 hours. That was pretty damn fast. So I would say the community is fairly enthusiastic to move forward with this, from what I can see.
Okay. Sam, I guess a good time to kind of intro you. You're with, what's the company? Arweave?
Arweave, it's
Arweave.
called.
Okay.
Yeah.
And if you could give a quick intro of yourself and kind of explain how you got involved in the whole RandomX thing in Monero land.
Yeah, so this was kind of an interesting story. It certainly wasn't planned. So I'm Sam, I'm one of the founders of Arweave. It's a kind of permanent decentralized web, essentially, on a different kind of blockchain that scales so that you can fit large amounts of data inside. And so the proof of work we use in our system is twofold. There's this proof of access layer, which requires you to prove that you have access to some previous random piece of data from the network, or randomly chosen piece of data. And there's also a normal sort of proof of work underneath that. And currently, at the moment, we're using SHA-2 and we'd like to keep things, one CPU, one vote, if possible. We're very aware that,
just to back it up, what is it exactly that you guys do?
Yeah, so it's a permanent information storage system at its base. It is a kind of blockchain that you can fit large amounts of data in. So the data stored inside the system maintains all of the properties you normally get with a blockchain. So it's permanently available, distributed across many machines. The signatures on everything are verifiable, and you get timestamps. This is pretty much the core of it. The second layer on top of that is this thing we call the Perma Web. So it's basically like the normal web, except everything inside it is permanent and time-stamped, like it would be on a blockchain, because in fact, it is on a blockchain. So yeah, so our system, the storage of that data comes as a sort of useful byproduct of the consensus mechanism itself. And the consensus mechanism is in two parts. There's this like proof of access part, so you have to prove that you have access to the old data, and there's this normal proof of work part. Yeah, so we were sort of aware that like we were very quickly going to reach the limits of this normal proof of work, and people would start designing, ASICs to cover it. It's SHA-2 so it's not very common, but it's also definitely far from uncommon. And so actually it was around this time last year that we started talking about the idea of programmatic proof of work as a solution, or at least as a method to get one CPU, one vote over a long period of time. And so we built our own sort of implementation around December time, I think. But then, we saw the work with RandomX, and we quickly came to the conclusion that this was probably the implementation to go with. So then we were looking around for an auditor to try and get the thing audited. Because, at the time there was no, at least public information on the audits. And sure enough, when we spoke to Trail of Bits, they were saying, oh, yeah, well, we actually just spoke to Monero about this. So they got us in touch, and yeah, things kind of went from there.
Very cool. So, you guys were looking to utilize RandomX and audit it on your own, even if Monero wasn't implementing it.
Yeah, exactly. So we had our own kind of implementation, but I think it was fairly bare bones in comparison to what RandomX does. And
so what is your kind of take on RandomX? What's your, do you have an opinion there on how successful you think it may or may not be in thwarting ASICs?
Well, I think it definitely has the best logic for how an algorithm can be ASIC resistant out of all of the supposedly ASIC resistant algorithms we've seen so far. But people are exceedingly resourceful. I wouldn't be surprised if in like 5 years we end up with RandomX processors, that are actually able to execute proper programs, but just happen to also be built to cover RandomX. We'll see that.
Howard, what would your response be to that? Would that just be a computer at that point?
Oh, sure. That's actually one of my side projects is to implement Conway's Game of Life on RandomX.
That would be amazing. Huh.
So yeah, certainly that that could happen, and it would just be another processor. Yeah.
Yeah. Yeah, when we were going through the sort of design process for our own one, what we were thinking was, in the absolutely ideal case, you probably just want some sort of program generator for literal x86 Intel CPUs. if you could, but there's a whole bunch of reasons that doesn't really work. But that would be, I guess, the complete ideal.
Sure. Except, I mean, and we thought about that and we said, but we don't want to be architecture specific. We don't want to leave all the ARM CPUs out in the cold. So
yeah, that's definitely true. And also, I mean, at that point, you end up becoming company specific as well, because each of the CPU manufacturers ends up being slightly better at one thing than the other, and so on.
Oh, true. Yeah.
So just to kind of have an overall understanding in terms of the auditing process and where we're at. So there's 3 different companies that are going to be auditing RandomX. I know Trail of Bits, right? Which I guess you guys are essentially paying the bill for, which we greatly appreciate. And then I believe there's 2 other companies as well that are going to be doing the audit.
There's actually 4 in total. So
okay.
Yeah.
And Trail of Bits is about to finish up. They're scheduled to deliver their final report to us tomorrow.
Yeah, it should be exciting. The first part came back pretty positive, I think.
Yeah.
So how did it break out funding wise? So the community raised funds for 3 of them or something, and then
that's right.
Okay.
Yeah. So we're covering Trail of Bits, and the Monero community are very kindly covering the other 3.
And then just so we kind of have an understand what exactly happens during one of these audits. Is there a way to kind of explain that? I mean, what is the process of auditing something like this?
It's kind of we tell them, here's the GitHub repo, here's all the code, and they go through it with a fine-tooth comb.
Okay. And so, I mean, obviously, I guess once so you're saying there'll be a report already potentially by tomorrow, you said?
Right.
I think they'll probably need some time to, I mean, at least on the halfway through report, they took some time to make some edits. So I don't know if it'll be public tomorrow, but certainly very soon after.
Mm-hmm.
Right.
And so would they be kind of chiming in on how effective they think the proof of work will be in terms of thwarting ASICs, or that's not something we learn until it's out in the wild, and really they're just more looking at kind of the math behind it and whether or not there's any gaping flaws or something?
Yeah, for this review, I think they're just looking at the cryptographic primitives we used, and just looking for, simple bugs.
Okay.
In the code.
Yeah. They took a pretty in-depth look at the cryptography, but they were more looking at things like, does it lose randomness during the execution process? Like, does it lose entropy? This kind of stuff. I don't think they're going to take a position on whether it'll be ASIC resistant. I think we'll have to find that out in the wild.
Mm-hmm. So in the scope of all crypto, is this fairly unique in terms of proof of work and what's happening? I mean, is this kind of a new kind of a little bit of a paradigm shift in terms of how proof of work is done?
It's definitely a paradigm shift. I mean, there are other projects doing similar kind of implementations, but as far as I'm aware, maybe you know more, Howard, but there's nothing like this actually in production right now. Yeah,
that's certainly true. The closest thing that gets mentioned a lot, like in the same breath, would be ProgPow that the other group has developed, and that's really, it's actually a much simpler algorithm, and so it doesn't really compare as far as capability.
Yeah, it's funny. Just before we started our own implementation, which we eventually, we just decided RandomX was better, so we'd use that. But before we started, we looked at ProgPow, and it just wasn't as in depth as we'd kind of hoped. So then we thought, well, we'll just try, building our own VM and see how it works. So I'd say that's kind of, well, I think they've made it so that it's supposed to work okay on GPUs, and as a consequence, it really isn't very CPU-like.
So is that kind of the major difference then between the two, RandomX and ProgPow? One is a little more friendly towards GPUs. Is that
I suppose from a user level view, that's going to be the most obvious difference. Yeah.
What would you say the other differences are?
Uh, the to the degree of machine modeling that's gone into the algorithm.
The ProgPal instruction set is much simpler than RandomX, like by orders of magnitude, I think even.
Yeah.
And so, I mean, so was there intent there for them to design it the way they did for the purpose of not kind of killing off the GPUs? Was that was that the idea there?
Well, their idea was to be GPU centric. They're coming
Yeah.
from the Ethereum community that's already strongly GPU oriented. So, that was their focus.
Mm-hmm.
And I think they did that pretty well. Like, I think that'll work out all right if they end up using it in practice.
And so, Sam, what's your? I mean, I think we're pretty clear on Howard's opinion on the direction we want to be moving in terms of one CPU, one vote, kind of being the ideal. Howard, not to put words in your mouth by any means, please chime in otherwise. But what do what's your kind of opinion there on a philosophical level in terms of creating distributed networks? Is that kind of the holy grail to have it where anyone can use their computer to, support the network?
Yeah, absolutely. Like, as far as I'm concerned, one CPU, one vote is pretty much the way it should be from a philosophical level. But also we have a sort of more practical incentive, which is in our network, users decide together what content should and shouldn't be inside the system. And as a consequence, it's very important that we keep the I guess you would say, geographic concentration of the hardware that is good at mining globally distributed, because then you get a sort of global voice on the kind of content that should be in the system. Whereas if you have something that's very ASIC vulnerable, these hardware repositories typically end up in like a few very small places, where the electricity is particularly cheap, obviously.
Mm-hmm.
Right. I mean, you can already see that that's how it all happened with the Bitcoin network.
Yeah.
Right. So the idea being it becomes a more egalitarian mining system.
Exactly.
Right.
So more people get to express their point of view on what should and shouldn't be inside the system is where we're going with it.
So just back to the CPU versus GPU for a second. So are we effectively kind of killing off GPUs here with RandomX? What is the actual estimated effect?
Well, yeah, that's still a good question. If you look at the benchmark results we have now for the NVIDIA miners, first of all, it's always a faster hash rate than Kryptonite. So just the RandomX algorithm itself is a little bit faster, but the speed up is much faster for CPUs than it is for GPUs. And I think, say a 3-to-1 advantage to CPUs is going to be typical. Now, with that said, GPUs are still easier to scale, right? You can buy a motherboard with 10 PCI slots in it and put 10 GPUs in it if you really want to. So, from an extensibility perspective, GPUs will still have their place.
Okay, so they won't totally be booted off the network. It's just they'll be less competitive than they were.
Yeah.
What's this fast mode versus light mode? Just trying to understand the purpose of that and what that looks like.
Well, the normal mining mode is the fast mode, and it requires over 2 gigabytes of RAM. Okay, so that's going to be the mode you use that's most efficient for crunching hashes. The light mode is for smaller machines that are memory constrained that you just need to run a full node. So the light mode only requires 256 megs of RAM. So that will run comfortably on a Raspberry Pi.
And this was necessary just so we can kind of keep those nodes alive.
Yeah, it was necessary to keep verification speed at about the same as kryptonite verification.
Okay. Do we see that with any other proof of works? Kind of this fast mode, slow mode thing, or light mode? Is that a
It may not formally be there, but if you look at a lot of algorithms, there's always this time memory trade-off. You'll see that abbreviated in documentation as TMTO. And so you'll see that in descriptions of a lot of these algorithms. If you look at cuckoo cycle or anything else, that's always being discussed somewhere. It may not be leveraged as explicitly as we're doing here, but it is always a case that when you try to use less memory, the algorithm gets much slower to compute. And we just tried to find the balance point where we're using a small enough amount of memory for practical nodes that is still fast enough for practical verification speed.
Mm-hmm. And then how does this, I saw talk of botnets and, one of the criticism being that I guess this could lead to potentially more botnets, others saying it would lead to less, I guess because of the higher memory requirements. How do you see that playing out in terms of botnets and how RandomX will affect that?
Yeah, I guess part of the question depends on what you consider the average PC these days. I mean, my old laptop that I just retired had 8 gigs of RAM. If it had a rogue program on it running and using 2 gigs of RAM, I would know that immediately because that machine would be unusable.
Yeah, we sort of like the idea that you might be able to do, for example, in-memory mining at a reasonable rate. Because so in our system, people store web applications. And so one of the things that we have to work around is like, how do you compensate the gateways that people talk to when they're not using a sort of Arweave aware browser, in order to get on the network. And so we think that people doing very small amounts of mining in their browser is not necessarily the worst thing in the world. I think it's actually probably preferable to some forms of advertisement. But we'll see how it plays out, I guess.
Yeah, I certainly think it's an interesting idea. I mean, we saw CoinHive taking advantage of that for a while. Are they still around?
Yeah.
Is that still a thing, or has that?
I don't think so.
Okay.
No, CoinHive shut down in March. I think either just before or just after the Kryptonite R hard fork.
Mm-hmm. So now potentially things like that may come back. It may once again may make economic sense for them to exist, or
yeah. I mean, the problem now is that the browsers themselves are sort of cracking down on this kind of thing, which will definitely make it. I think it's a bit of a shame, honestly. I think it's cutting off a route to monetization of web applications and web services that, it's a bit premature at this point.
Yeah, I agree. I thought it was a really interesting potential business model there that people could take advantage of. Howard, what do you think? What was your kind of opinion on the CoinHive thing?
No, I agree with you. It had strong potential. When websites do it out in the open and they tell you up front, hey, we're going to start mining on your machine, I think that's great, right?
Yeah.
When they are, surreptitiously doing it through malware, obviously that's no good.
Yeah.
Yeah, I think some people will go so far as to say botnets themselves aren't really a problem, though. Do you think that's just there's no argument to be made there, or is there potentially some reasoning as why we may be okay with botnets supporting the network?
Well, botnets are going to exist one way or the other, right? And they could be sitting there scanning your hard drives and stealing all your personal data, or they could be sitting there crunching a mining algorithm. In the grand scheme of things, this is probably one of the least harmful things they could be doing.
Yeah, that's definitely true. I think, botnets obviously not a great thing, but also like it's basically the minimal amount of harm they can do to your machine. It's also very obvious as well. It's hardly like you can be very surreptitious with this kind of mining.
Right.
So I guess that's something we won't know until RandomX goes live as to what kind of effect that's going to have on the ecosystem in terms of botnets. Right.
Yeah, it's not clear.
Okay.
Until.
I would be surprised if it had very much of an effect at all. What do you think, Howard?
I would say, okay, I expect to see older machines, just dropping out of these botnets because they just can't keep up.
That's interesting. Yeah.
That's about it, though. Yeah.
And then one of the other comments I saw people talking about RandomX was the potential for something like a supercomputer to now be competitive, since now I guess it's all CPU based. Is that something that would be a concern, or what's the counter argument? So
no,
what is the argument against a supercomputer taking over the network?
There's a couple of things, but the most easy one to explain is just cost. All right. If you look at the equipment that goes into a supercomputer and you look at the prices of those components, for example, if you go on a Newegg right now and you try and look up a 16 gigabyte DDR DIMM stick, right? It'll cost you around $50 to $80. If you try and find a 32 gigabyte DIMM, it'll cost you around $500. Okay. The more you go up in scale and performance in computing hardware, the price goes up exponentially. And so when you look at $1 billion worth of supercomputer, you're only looking at about, $100 million worth of PCs for the equivalent horsepower.
Mm-hmm.
All right. So
but it probably will lead to the generation of more sort of home supercomputer-like clusters. Like I'm thinking of those Beowulf setups that people used to make.
Oh my God! All right.
Yeah, throwback. But people will basically just be building big compute clusters. So it's certainly more supercomputer-like than the current mining setups, which are very specific.
Fair enough. Yeah. True.
And one day they could maybe reuse those setups for computation outside of mining, which might be kind of interesting.
Yeah, they could go back to Boeing or SETI at home.
Right, exactly.
So I guess we should talk a little bit too. I know we initially talked about it, Sean. So you said you had kind of discovered RandomX on your own as being a potential solution for what you guys were looking to do. But also, I guess OSTIF, who I'm not familiar with them too much, they were also involved as well. They were kind of the connector between the Monero community and you guys. What role did they play? Because I find that to be interesting.
Was that to Sam or
Derek? Yeah, to either you or Sam. I was the role that OSTIF played in kind of bringing everything together here.
I assume they spoke to you guys first, Howard.
Yeah. So, OSTIF, Open Source Technology Improvement Fund, they actually coordinated the review teams for the Bulletproofs work. And so, the guys in the Monero Research Lab were already familiar with them, and, they worked well together. And they put us in touch with a couple of the audit teams that we eventually wound up hiring all of them, but so they had the connections to the audit teams. They put us in touch with Trail of Bits, and it was during the time that we were negotiating with Trail of Bits that those guys said, "Oh, we have another customer who's just hired us to do this review," and that's how we got connected to Arweave.
Yeah.
Very cool. So do they play a large role in the open source community?
I guess that's, their role is, facilitating new research. Yeah.
Have they been around for a long time? I don't know much about that. Like you said, they I guess participated in the bulletproof thing as well. Are they relatively new, or is this some an association that's been around for a long time?
I would say they've been around for a while. Yeah.
Okay. Yeah, I'll have to have them on. I tried reaching out to Derek, but I think it's interesting that they're kind of being a connector and helping push this stuff along. I mean, RandomX, it's moved at a pretty surprisingly fast pace, right?
I'm happy with the pace. Yeah.
That's a compliment. I'm very impressed in how far you guys have come, how quickly you've come, considering it's kind of breakthrough technology here, and you're already looking to implement it into Monero. Sib,
well,
go ahead.
It's already it already works in Monero. We have the pull request on GitHub, and several people have tested it successfully. The Monero guys are actually going to roll it out in their own network like next week. So.
Oh wow, that's interesting. We've been running a testnet for a few weeks now, just going very well, I think. But okay. I didn't realize Monero, are they running like a main network or?
I think it's going on their main network next week. Yeah, they've been doing testnet for this past week or two. Yeah.
Oh, that's very exciting.
Yeah.
Is there anything you think we could expect to learn from that, from their implementation of it?
Well, I'm certainly going to watch closely.
I think we all will be.
I guess given the size of their network, though, it's not too much of a test, though, right?
Yeah, I mean, I don't know what their transaction volume is like or anything, but yeah, I'm sure it would be like the Monero testnet, right? I don't know.
Right. So Sean, go ahead, Sean.
Sean?
Sam,
I'm sorry. I'm sorry.
All right.
I was gonna.
Yeah, I was just going to say, I think the real test is going to come when people start experimenting with ASICs and maybe further work on GPUs with it. Like that's the main concern I have. I'm pretty sure after the audits are done that the code base will be fine. I don't have so much worry about transaction volume, that kind of thing. But I am very interested to see what happens when the guys that's only job is to make hardware for this stuff, solely focused on it, really put their mind to it. It'll be really interesting to see what happens.
Oh, definitely, yeah.
Yeah, I was gonna say. So, do you have an opinion on Monero in general? This being for Sam, not the imaginary Sean. Other than looking to utilize the RandomX tech, are you actively involved in Monero? Is it something you're interested in?
Yeah, I mean, I wouldn't say I was actively involved, but I've been around the crypto space for quite a while, I guess, and I've always really liked Monero. It's my favorite privacy-preserving token, I guess. I think that the way that you guys approach it is, really solid, and the cryptography is simpler, and that's typically better with cryptography. So,
yeah.
I mean, it is like there's just less chance to break it accidentally. So yeah, I mean, I bought some more Monero during the winter time, so I was rather happy with that, and I'm quite looking forward to using it at some point in maybe a shop somewhere.
Are you going to be coming to Denver to the MoneroCon?
Potentially. Okay. My schedule is like pretty full, but yeah.
Could be a good opportunity to use some Monero, potentially.
That'd be nice.
Howard, you're going to be there, right? I think are you giving a talk?
Yeah, I'm giving a talk. The title is ASIC Resistance Factor Fantasy.
I think we know how that one ends.
Yeah.
Actually, I don't think we actually know the complete ending yet.
Yeah, we'll know in a couple of years.
Yeah.
Yeah, I'm excited for Denver. We're going to be throwing a party there as well. I don't know if you guys are aware. If you're going to be in town the Friday before MoneroCon, the night before it starts, we rented a house, Casa de Monero, we're calling it.
Oh God. I am literally like, getting off of an 18-hour flight at like 9 p.m. Friday. So I don't know if I'll be in a partying mood.
Yeah, swing by for a drink.
We'll see.
Okay. So Seb, is there anything else we could learn about Arweave that relates to Monero, or I really don't know much about it at all. Anything that you want to?
Well, I mean, it's a decentralized permanent web. I mean, you could definitely build applications on top of it that use Monero for payments. And from a personal note, I think that if you want a privacy-preserving mechanism for doing that, that's probably the best option you have. Yeah, we actually work more with a Monero fork called Loki that have a kind of, I guess you'd call it, an incentivized Sybil-resistant Tor network that they're building using service node architecture underneath. Yeah, kind of Monero fork. Yeah, and we've built this interesting thing that we call Silo, which is kind of like a privacy-preserving layer on top of the Arweave's Perma Web. But this is not quite, this is not quite Monero related, I guess, but it's sort of tangential. But yeah, if you're interested in decentralized webs and these kinds of things, then definitely check us out.
Yeah, I met those guys recently, the Loki guys.
Right.
So how long has your blockchain been around? Is this a relatively new project? What's the history?
Yeah, so we started about 2 years ago now, and we launched the main network a year ago. In fact, almost to the day. We've got a anniversary coming up on Saturday, I think. Yeah, it's been pretty exciting recently, actually. We've seen a massive uptick in people building applications on top of the system. It's really nice because, the applications are really just web apps, but they're kind of decentralized by default. So you write them in JavaScript, CSS, HTML, which makes it super simple. But of course, when it runs on top of the network, you get this decentralization effect that's very effective and very powerful.
So who would your competitors be? Who else is kind of working on similar tech?
I mean, so everybody always says like decentralized storage, but we don't really see it that way. The really interesting thing about Arweave is the permanence factor. So everything you put inside the network is just there indefinitely. And in that regard, I don't think we really have any competitors, actually.
Web.archive.org.
Yeah, I guess so. That's true. So in the centralized space, although we really don't see them as competitors either. Like the first thing that was built on top of the Arweave was this little website you could go to that had a library of torrents from the Internet Archive. It was called like the CRIAG or something, the Censorship-Resistant Internet Archive Gateway. The idea being that like you could get to this archive from anywhere in the world, and your access to it could never be revoked. Yeah, even in countries that didn't have access to the archive through normal means. So, we're very much along the same. I guess we're very aligned with the Internet Archive, and we'd rather work together than see each other as competitors.
Yeah, that's great. That's to have complementary technology like that. Yeah.
Yeah.
Howard, what's your view on kind of blockchains being used in this way versus the more traditional use of something like Monero, using it for purposes of value transfer?
Right, and so that's the perfect thing if you want to keep data around forever, right? And it's frustrating to use a web where websites disappear or die or something, right? So yeah, I see it solving an interesting problem. I like that.
But do you see these things ultimately being built on existing, blockchains like Monero or Bitcoin or something, or do you see it being its own thing?
Definitely, it's its own thing because we don't want to put multi-megabyte websites into the Monero blockchain.
Yeah, that would be kind of crazy.
Yeah. Oh, so no, definitely, it's its own application field, certainly.
Mm-hmm. And yeah, so are there people looking to kind of just build similar applications on top of Bitcoin, though?
I mean, not as far as I'm aware. So we had to, like, the consensus mechanism in our algorithm is pretty different than you'd be able to do with a normal blockchain. Like, for a start, not every node in the network has to have every block, which fundamentally changes the scaling mechanics. So if you were to just try and like pile data into Bitcoin, it would be extraordinarily expensive, because you're basically saying every single person that takes part in this network in the future forever should store a copy of this. Whereas we took this other approach that said, okay, well, not everyone has to store everything, and everyone is rewarded proportionately to the amount that they do store. So I think it would be very difficult to sort of backport this new kind of consensus mechanism into existing blockchains.
Mm-hmm.
And similarly, you know, it like is a terrible platform on which to do smart contracts. This mechanism of consensus really just doesn't work for those kinds of things where you can't memorize the state quite small. Yeah, so at that point we just call out to things like Ethereum. You know.
And what was kind of the impetus for you guys starting this project?
Yeah, we have you read 1984?
Yes. Yeah.
So, you know, Winston, the main character, his job is to censor and delete records of history. Well, we wanted to make it so that that wasn't possible anymore. And in fact, recently, I think we just had you know, the phrase 0 to 1. Well, I think we just reached our one moment, which was, yeah, there was an article put out in Russian propaganda, or yeah, English language Russian propaganda outlet called Sputnik, that was remarkably pro-Ukrainian about a recent military incident. And someone snapped a copy of this and put it into this archive, well, on the Arweave. Yeah, and then we don't know whether it was the Russian government or whether it was just Sputnik working on their own, you know, on their own steam. They deleted this copy and they censored it, and they replaced it with a copy that was much more pro-Russian. And but now there's, you know, like 550 copies of this piece of information distributed globally across like 80 different countries. It's basically impossible to get rid of, and those people have an incentive to store it. So yeah, it's past the point where the Russian government could censor it, and that, I think, is yeah, for us that was a real moment where we're like, wow, this is pretty much what we intended to achieve.
That's pretty cool.
Yeah.
Thanks. Yeah, we were really excited about it.
Yeah.
Very cool idea. So what kind of apps are you seeing? I mean, are people trying to build like the next Twitter or Wikipedia on?
Yeah, so we're actually working with a group called Everypedia, which was started by one of the Wikipedia founders, to, sure enough, put the entire encyclopedia onto the Blockweave. So that's definitely one application, but we're seeing people build all sorts of random and interesting things. Like someone built a sort of decentralized Quora, except instead of having upvotes, you have tips. So if you like to post, you just tip it the quantity that you thought it was worth, and then there's like a built-in economic incentive for people to write good quality answers. And also it builds up this sort of permanent archive of knowledge while you go. So it's really interesting. What we found is that we had all these ideas for what people were going to use the network to build, and pretty much all of them were wrong. Instead, they just built way more creative and imaginative things than we'd ever really expected. So that's really exciting to see.
Very cool. Yeah, I do recall other projects trying to kind of attempt to do the same thing. Don't know forget the names off the top of my head. Was Feathercoin one of them, or I remember one of the early.
So I think there was this project called Alexandria Coin or something like this, that we actually found quite a while after we started Arweave. But as far as I'm aware, they literally just had a blockchain that they were putting data into, which unfortunately doesn't really have very good scaling mechanics.
Right.
Yeah, but you know, it's exactly the same kind of idea for what they were going for. So we're very aligned on that, certainly.
Very cool. So do you see Monero and your community working together in any way in the future beyond sharing the technology of RandomX?
Well, we're certainly happy to. I mean, we'll have to see where it goes to, I guess. We've certainly seen quite a few people from the Monero community join us on our Discord development channel, which is where, you know, all all the builders in the community hang out. Yeah, and we're just happy to work together, happy to talk to people.
Very cool. Howard, you got any other questions for Sam here?
Oh, yeah, not right now, thanks.
How about Sean? Is he still
All right, guys. I think we covered it pretty well. I don't know. Do you have any other things you want to talk about regarding RandomX?
No, I think I'm good at least.
I mean, I'm excited to hear how that report comes out.
Me too.
Yes, so you think the community will be learning about this as soon as tomorrow, getting some insight?
Well, we'll see it for the first time tomorrow. If there's any edits that need to happen to it or whatever, then it could be a couple of days.
Okay. Thanks again, guys. I'm sorry there was some coordination problems in the beginning, some internet issues, but
hang on.
thanks for everybody.
I see a question on the chat.
Oh, okay. Let's check it out.
Do you see it?
Oh, how does Arweave incentivize serving data? Is that what we're talking about?
I can't see this chat, but that's an interesting question. The answer is we have something that's very similar to optimistic tit for tat, which is an algorithm from BitTorrent originally. The idea is that really basically, like, if you give me data, I'll give you data, and then very occasionally we'll just randomly give data to people and see what happens. And the equilibrium when you do this, it just tends towards everybody sharing data all the time. So we have a pretty similar mechanism. But on top of this, we also distribute new blocks and new transactions according to the rankings that one gets in this game. And this gives a sort of extra incentive, which ties it back to the mining incentives in the system. So in order to be a good miner, you also have to be good at this data distribution mechanism.
Cool.
Need money. Are you satisfied with that answer?
He asked again.
He thinks it may be gameable, is his response to that.
Okay. I mean, BitTorrent used a very similar system, and that at one point was carrying, I think, 30% of the internet's traffic. So yeah, that's certainly a good game you could win if you have some spare time and you think you can do it.
All right. Well, we'll keep an eye on the project. It certainly sounds interesting. Thank you for the contribution to the Monero community.
No problem. Thanks for designing RandomX. We're really super excited to be working with it. Thank you, Howard. I think we should kind of give a shout out. So who was everybody else kind of involved in RandomX? Trevador. What are the Howard? What are the names?
Yeah. Trevador and S. Chernik. I don't know if they've published their full names or anything, so I'll just leave it at their handles like that. Yeah.
Okay. All right, guys. Thank you. Thanks again. I appreciate it. And excited to see the next stage in RandomX, and looking forward to seeing it eventually on the mainnet here of Monero, hopefully come fall time. Thanks for having us on. Thanks, guys. Have a good one. Bye.
Take it easy.